Okay, let's take a look at one more problem where we are finding the area between two regions. So I've got the two graphs already graphed here. So -6 cosine theta is the pink graph. It's a circle on the left side. 2 minus 2 cosine theta is the blue cardioid that I'm seeing. If you want to look at these graphs on the calculator, again, just go to polar mode. Anytime you're looking at the graphs, make sure you're in the polar mode. I do want to go from 0 to 2 pi. And I know the circle is going to go out to 6 units, so I made the x go from -7 to 7. And you can go ahead and, oops, I have the second one turned off. You can go ahead and look at the two graphs to make a rough sketch. So the region that we're looking for says you want the area of the region common to the two graphs. So we're looking for the region that's inside both of them. So notice that's going to be this region here. It's all of this and then all of this here. And I'm going to just go ahead and do what we've done before. I'm just going to do the top half and do it by symmetry because the top and the bottom is going to be the same. So I'm going to find the area of this region. First step, if there's a point of intersection, we need to find that. So that's right here. So we need to figure out what this angle is. So we're looking for where's this equal to 2 minus 2 cosine theta. Now you can solve this by hand. But remember we talked about you can do intersection on the calculator. But remember intersections on the calculator you can only do in function mode. So we're going to go to our calculator, type in our two equations, and see where they cross. And this is where you have to keep changing the windows back and forth. Your x is your theta, that's your variable, and we only care about theta is greater than 0. So I'm going to set this up to 0, and 7 is fine because you'll be bigger than 2 pi. So let's go ahead and graph it. And I want to know the first time where they cross. So right here, this angle, this x, is this theta that we're looking for. So if I do my intersection feature, oops, I found the wrong one. Let me do that again. So when it asks for the guess, I want to be close to the angle that I'm looking for, which is all the way over here. So my angle is 2.0943, and I'm going to be using that going forward, so I'm going to store it as A. So theta is really 2.0943 something, and I'm going to label it on my paper as A, so I know that what I'm going to be using. And again, remember your angles in polar graph go out from the poles, so I would draw that angle in. So notice you have this little pink region. I'm going to shade it in pink. And then you also need this little blue region here. So really, in order to get the area of the entire piece, I need the pink region plus the blue region. So let's think about how I'm going to get each of the pieces. So let's look at just the pink for right now. So this piece right here. So we figured out this angle that we called A. Notice we also need this angle right here. That pink region is only bounded by the circle, the pink graph. So it's very important that you only look at that pink graph now. And the only thing you can tell by looking at this graph is that r equals 0. There is no way to tell what that theta is. You can have r equals 0 when theta equals 0, theta equals pi f's, etc. So I would double check what that angle is. So really you're trying to figure out when is this equal to 0. Now hopefully we can solve that pretty easily if you know your unit circle. If you don't, you can go ahead and again do an intersection feature on your calculator. Or let's look at the graph and see what happens. So I'm going to go back to my mode and go to polar so I can look at the graph again. And I just want to look at that circle graph. So let's turn off the cardioid for now. And again, here's my window. Okay, so I need to figure out what this angle is right here. Do your trace feature, and it always starts at theta equals 0. Notice that theta equals 0 is all the way over here when r equals 6. So if I trace it out, notice in order to get all the way over here, that is not theta equals 0. It's theta equals 1.5707, etc. That's exactly pi halves, right? Cosine of theta is equal to 0 at theta equals pi halves. So that's the angles that you need. So this is pi halves here. So in order to get this little pink little sliver, we're going to integrate from pi halves to A of just the pink graph, which is -6 cosine of theta squared d theta. So there's the pink. Okay, now let's think about this blue region here. So I need to add it to this blue region. Again, first thing I need is those angles. I do have this angle. I know we're gonna start at theta, which is A. And the other angle that I need is this one right here. Notice this blue region is only bounded by the blue curve. So we only care about this angle on the cardioid. So if you notice, you're looking for, the only thing I can tell is what the R value is. The R value is actually 4. So if you want, you can go ahead and try to figure out when this is equal to 4. Or let's go ahead and look on the graph. So again, I only care about the cardioid this time. So let's look at this. Let's trace it out. So the cardioid theta equals 0 starts there. And if I trace it out, that's exactly pi. Because remember, we saw the cardioid graphs before. It actually graphs the entire graph from 0 to 2 pi. So this angle here is going to be pi. So to get the blue region, we're going to integrate from A to pi, and only the blue curve, which is 2 minus 2 cosine theta squared. This will give me the entire area, but we talked about we're going to multiply by 2 so we can get this bottom piece down here. Go ahead and enter that into your calculator, and you should get a numerical answer of 15.70796.